Okay, so a couple more things with this graph. First of all, you might get asked to work out the average speed for the entire journey. Now, throughout this journey, we're moving at different speeds because the gradient changes, perhaps except for this middle section here where we're moving at a constant speed, we've said. But throughout the rest of the journey, we're moving at different speeds. So the speed is different for most of the journey. Okay, it's slow here and then fast here and then slower again. Okay, so you may be asked to work out the average or the mean speed. Okay, now there's two ways of doing this. First of all, you can use the equation mean speed equals total distance divided by the time. Now the total distance travelled in this journey is 300 metres and the time taken is 30 seconds. So if you divide those two, you're going to get 10 metres per second. Okay. Now the other way of doing it is to draw a line like this. Because this graph is symmetrical, you can draw a line just straight through it like this. So because it's symmetrical, I know that the speed is changing here, but it's changing equally here. So because it's symmetrical, you can draw a straight line through it, and then you can work out the gradient. Now we know the gradient here is, I like to draw a little triangle like this, the change in the y value over the change in the x value. Now the y, on the y-axis we're going from 0 metres up to 300 metres. So the change in y equals 300 minus 0, which is 300 metres. The change in the x value, we're going from 0 to 30. So the change in x here is 30 minus 0, which is 30 metres. And then the gradient equals the change in y over the change in the x value. So that's going to be 300, because that's the change in y, divided by the change in x, which is 30, and that gives you again 10 metres per second. It's the same, because that was metres and that was seconds. So it doesn't matter which way you do it, you get the same answer. Okay, now here's a bit more of a tricky thing. So on higher tier exam papers, you may get asked to calculate the speed at 10 seconds. So what's the speed at 10 seconds? Now the problem here is, to do this, you're going to have to calculate the gradient, because the speed at that particular point is changing. It's changing, okay, because this graph is getting steeper and steeper. So because the speed is changing, you have to work out the steepness, the gradient of the graph at that particular point. And the only way to do that is to draw what we call a tangent, okay? So you need to draw a tangent to the graph at that particular point. And a tangent is just a straight line that basically helps us to work out the gradient at that point. Okay, so we're working out the gradient here. We draw a nice straight line like that. And then you just need to work out the gradient of this line. Okay, so the gradient of this line between here and here, and between here and here. Okay, so the change in y over the change in x. So here we're going from 0 on the y-axis up to 150 on the y-axis. So the change in y here is 150 minus 0, which is 150 meters. Okay. The change in the x value is, we're going here from 1, 2, 3, 4, 5, 6. Well, that's about 5.5 there, I'm going to say. Okay, because it's halfway between 5 and 6. And then here we're going up to 10, 11, 12, 13, 14, 15, 16, 17. So my change in x here is 17 minus 5.5. Okay, now if you do 17 minus 5.5, that's going to give you 11.5 seconds. So therefore, the gradient at 10 seconds, so the speed at 10 seconds now, you need to work out the gradient. And it's equal to change in y over change in x. Now we know that, remember we've drawn this tangent here at the 10-second point. The change in y here is 150 meters. Okay, because it's gone from 0 up to 150. The change in x, we're going from 5.5 up to 17. Okay, so 5.5 plus 11 gives you 16.5, plus the 0.5 gives you 17, so the difference between these two is 11.5. So the gradient here is 150 divided by 11.5, and that's going to give you 13.04 meters per second. And you can see that that's greater than the average speed, and that makes sense because that's the gradient of the average, that's the average gradient, that red line, and the black line here is the tangent at this particular point, 10 seconds, and that line there gives us the speed at 10 seconds, and it comes out at 13.4, and that line is steeper than the red line, so that makes sense as to why that's a greater speed.